Dear friends, Maths Aspirants is a collective of mathematics students across India formulated by myself in 2017, and we used to arrange online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of that series, today we have a problem solving session on group theory. Mr. Aravind Vishnu is with us to engage the session. Mr. Aravind did his MSc from Cochin University of Science and Technology, and he qualified CSIR net with JRF and GATE examinations, and currently pursuing PhD at Amrita Vidyapeetham, Coimbatore. His broad research area is cryptography. Today, Aravind will discuss with our students some problems, selected problems from group theory. I am sure that today's session will be really helpful to all those who are seriously preparing for the upcoming IIT JAM and GATE examinations. I would like to express my thanks to Aravind for joining with us. I welcome everyone to this program. Welcome, Aravind.
We'll begin with a set of all matrices of the form 2x2 matrices of form x, 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 x. I mean, by the way, if problems has been discussed before, if I'm repeating it, please feel free to tell me. I'll just skip that. So, if I have matrices of the form 2x2 matrices of the form x, 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 all 4 x's. So, under matrix multiplication. So, will this be a group? You people can unmute and say, or like you can send the chat. I mean, use the chat, whichever is convenient. Will this be a group under matrix multiplication? Okay, I got an answer saying no. Okay, 2 people are saying no. I mean, why do you say no? Any idea why? Which property of the group do you feel? Do you reckon that is violated? Inverse. Okay, fine. So before that, let me ask you the first question. You should have asked me. Exactly. Somebody was saying x not defined. Exactly. So where does x come from? The question is, where does x come from? So if x is coming from integers, of course, the inverse is not defined. And if x, I'm saying, suppose x is belonging to, say, rationals. Now, I mean, we don't need a, Sayanta, we don't need a field to define x. We need a, like, a ring will do. So what happens when we have x belongs to rationals? What will happen? Okay, somebody is saying like identity is an issue. So I mean, will this be an issue again if we pursue to? If persist to the case when x is a rational number, x is a rational number. So now let me see. So what happens when I'm taking a product a times b, e, e. So what is the product? What am I getting here? I'm getting 2ab, 2ab. I mean, feel free to ask if I'm skipping it, if you feel that I'm skipping steps. So, is that fine? Is that fine? 2ab, 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 2ab. So, the closure property is satisfied. And associativity. I urge you to somebody is saying identity doesn't exist and matrix is not invertible irrespective of x. Okay, fine. Chaitra is saying like irrespective of whatever the x may be, identity doesn't exist as well as it's not invertible. Fine. Let us see. So suppose that what happens when I'm taking let me for now let me consider let me take a map from A star B going to 2AB. I'll consider this map A star B going to 2AB. Fine. So will this be a binary operation, and can it be a group under, I mean, if A and B are taken from rationals and A star B going to 2ABs, will that be a group? If under star, will a rational set of rationals be a group under star? Let us see. Of course, it is. I mean, closure is there. I mean, somebody is saying yes. Any objections? So A star B goes to 2AB. So it is closed, of course, and associative property is granted. No issue with that. So we'll go for the identity. What is the identity? A star E should be equal to A. Yes or no? And A star E
Yes,
will be
sir.
2A. That will be 2AE. That will be A. Any issue now? So can I write E is equal to 1 by 2?
No,
Yes,
it
Why?
should be not equal to 0.
yes, sir.
Exactly. So I should remove something from here. Got a nice point from there. I mean, I appreciate that. Exactly, that is what I was looking for. So if x belongs to Q removed 0, singleton 0, then can I have this? E is equal to 1 by 2. Can I?
Yes.
Yes. So will E is equal to 1 by 2 be the identity? Of course it will be, right? Because A star 1 by 2 will be 2A by 2 will be A. Similarly, E star A will be again same. A star 1 by 2 equal to 2A by 2 will be, as well as the other way. Commutative, so we don't bother about that. Now for the inverse, suppose I have A star B equal to 1 by 2, implies 2AB equal to 1 by 2. So what will be B? Implies B is equal to 1 by, can I? Can I write this?
Yes, because A is not equal to
Yes.
0.
Because it is not equal to 0. That is why we need this condition. Okay. So now back to the question. Will x, suppose x is taken from Q removed 0, will that be a group?
Yes.
Yes.
Anybody still saying no? So anybody still have a difference in opinion? Like, we can still show this, but I mean, it doesn't mean, I mean, A. It's all the same. I mean, all these things, A, 4 A's. I mean, we are repeatedly single A. All these things are the same because we are doing component-based operations. So whatever the matrix multiplication which we did, actually it mapped A comma B to 2AB. That is what it mapped, right? Right.
Yes, sir.
So solving this will help you. I mean, will directly yield this result. I mean, this one. Yes or no?
Yes, sir.
Yes. So I think we are good. I mean, any questions on this thing? Any like bottlenecks? Anybody? Any questions? Shall we move on to the next question? I mean, this is just a warm up. Like how deep you know of the properties of groups, just to know that. So like let me take one another result. Say one another. Suppose x belongs to real numbers, and let it be a comma b. Why do I go against conventions? So Let a comma b element of real numbers, and I'm defining a star b equal to a plus b plus ab. Now, same question, will this be a group? Will R be a group under star? Somebody's mic is unmuted. Please check that. So a star b is equal to a plus b plus ab. What do you feel?
No. No.
Okay, somebody says no. Why? Which property do you? Same question. Which property do you feel is getting violated?
Identity property.
Which one?
Identity.
Identity. Okay. Anybody else? So, can I make this right somewhere by removing some number? Any idea?
Yes, -1.
Exactly. So, if I take AB belongs to R minus -1, now will this be a group? Will this be a group? Anyway, let's check. Let's check for the closure. Say, first of all, say A star B equal to A plus B plus AB, which can be written as, like, the only possibility is that this can be -1. So if A plus, I mean, the only possibility for it not becoming closed is that A plus B plus AB equal to -1. So the case is A plus A times 1 plus B plus B equal to -1, which is A to 1 plus B equal to -1 of 1 plus B. And we don't have -1 in our set, so B plus 1 won't be 0. So we can cancel them out, and this implies A equal to -1. Can it be? Can. I mean, do you see any contradiction there?
Yes, sir.
What is the contradiction?
A belongs to R -1.
Both A.
Excuse me, come again, because A. Of course, we don't have -1. How will A assume -1? How will A assume -1? We don't have -1 in this thing. So that's a contradiction. I mean, do you get that?
Yes, sir.
Okay. So anyway, associativity, you can just, that's simple calculation, but I mean, it's easy thing. You can do that. So for the inverse thing, Anambika was saying both A and B are from the same collection. So do you mean that like both A and B cannot be -1? Yeah, I mean, that makes sense. The same thing I also mentioned. So what happens? How does the identity look like? A star E should be equal to A. And what does that mean? That means A plus E plus AE should be A. That means E plus AE should be 0. That is E into 1 plus A should be 0. And I hope you know concept of zero devices. Yes or no?
Yes, sir.
So both E and 1 plus A, the product between equal to 0 means either 1 plus A equal to 0 or
Or 1 plus A
is equal to
or
0.
equal to
E equal to 0. But can 1 plus A be 0?
No.
No,
no.
why? Because we don't
No.
have -1. Yeah, exactly. So this implies E equal to 0. See, this is one example of 0 becoming the identity involving a multiplication in the binary operation. Still, though we involved a multiplication in the binary operation, still we have 0 as the identity. And the computation of inverse, I think it's Simple thing. I mean, just the same way you can just compute. I'm leaving it to the audience. Like I'll just hint you how to do that. I mean, the same thing. A star B should be equal to 0. That implies A plus B plus AB equal to 0. And you are supposed to group it like A plus B into 1 plus A to be equal to 0. Now, this is just a matter of side changing or additive cancellation and multiplicative inversion, whatever it is. That will take you to the answer. I mean, I'm not doing it completely. Anyway, so is that clear to you? So that will be but this operation will not make real numbers a group unless -1 is removed from the set. Fine? All clear?
Yes, sir.
Yeah. So, till now, any questions? Any questions? Okay, yes. Now we'll do some result-oriented problems. So I'll give you the question. Maybe you can show the question. So can you see the question? How many elements of the group Z50 have order 10?
Aravind, could you zoom that question? Then it will be more visible.
Yes.
Yeah, it's okay now.
That's a screenshot, so I don't know about the clarity. I'm not sure about the clarity, but still.
Yeah, it's clear. No problem.
Okay. So how many elements of the group Z50 have order 10? Anyway, I'll give you some 2-3 minutes to have a discussion. So you can unmute and just have your opinions. And if it's correct, we'll agree on that and we'll move on. So please, I'm inviting opinions. Yeah, have a message. Like
It should
say
be
4
4
elements.
elements. Option B.
Option B 4 elements. But how do you say that?
Since Z50 is commutative and so phi 10 Euler phi function. Phi 10 gives 4.
Exactly. So we have a theorem, like if it is a cyclic group, then phi of 10 will be the number of elements of order 10. Yes or no?
Yes, sir.
Yes, that is the theorem. So if we have D divides N, where D is the order of D is the order which we require and N is the order of the group, then we have phi of D elements of order. And if D is the group with cardinality N and D divides N, then phi of D elements are there of order D. But is that generally true? The question is, will that be true generally? Let me ask you the case where, say, I'm considering Z7 cross Z11. Z7 cross Z11. Or like, let's go with Z7 cross Z7. I'll just rephrase my question. How many subgroups are there for Z7 cross Z7?
The number
idea?
of
Number of
divisors of 49.
Number of devices of 49, like sigma of 49. Number of devices, that will be 49 has only 3 devices. 1, 7 and 49. So only 3 subgroups. So can you give me an element of order 49 in Z7 cross Z7? Is that possible?
No.
Why? See, we have told that if order of G equal to n and D divides n, then we have phi of d elements of order D. So if we have cardinality of G equal to n as well as n divides n, then why not phi of n elements? I mean, there should be phi of n elements of order n, isn't it so? I mean, where is the catch? Where did we miss something? Did we miss something somewhere? So the result is if cardinality of G equal to n, exactly, we need that theorem to work on cyclic groups only, and for non-cyclic groups, for non-cyclic abelian groups, that need not work. So in our case, so it's not a cyclic group, so we don't have elements of order 49 here. But now back to the question: how many elements? I mean, how many subgroups are there in Z7 cross Z7? I mean, this question was asked in JAM like 2017 or 18 somewhere. I remember seeing this question somewhere. So, like, say, the possible devices. I mean, this is a good start. I appreciate whoever that told me that. So 1, 7, and 49 are the possible devices. So, can we look back to Lagrange's theorem? What does that say?
Order of subgroup should divide the order of group.
Exactly, order of subgroup should divide order of group. So, what is the possibility of a subgroup? Anyway, in Z7 cross Z7, one element will be 0, 0, which is having order 1. I mean, of course, under addition modulo 7. So, this will be having order 1. So, rest we have total 48 non-trivial elements left, of which what can be the cardinality of a subgroup, non-trivial subgroup. We have devices 1, 7, and 49. So what can be a possible cardinality of a subgroup of Z7 cross Z7?
1, 7, 49.
7.
7. Yeah. I mean, 1 and 49 are corresponding to a proper subgroup.
Okay.
Yeah, we are concerned about sorry, that is improper subgroup, and we are concerned about only proper subgroups. So now let's see this how many. Okay, what will be the structure of a subgroup? We'll have identity as well as element A1, A2, A3, A4, A5, and A6. Okay, yes or no?
Yes, sir.
Yes. So all these elements are all having order 7 for sure, and identity. So in each subgroup, how many non-trivial elements will be there? In every group, there will be identity. So except identity, how many elements will be there in each group, each subgroup? Just look at the screen. 6. Yeah, that's it. So this is actually a partition of 48 elements into 6 each. So how many subgroups now? Each subgroup has 6 non-trivial elements plus the identity. So how many total subgroups do we have? 8. Exactly. Yes or no? 48 divided by 6. That will be 8. I mean, any issue with that? Any props? So that will be 8. So number of proper subgroups will be 8, as well as the whole group, as well as the trivial group. So we have trivial subgroup. So we have total 10 subgroups for Z7 cross Z7. Is that clear? Is that clear? Hello?
Yes.
Yeah. Okay. So we have, we'll move on to the next question, and we'll just, we have finished something with the billion group. So why don't we try something on permutations? So how many number of, I'm considering set 7, S7, the permutation of 7 elements. So how many number of elements of order of A equal to 12? Set of all A such that, of course, in set S7, such that order of A equal to 12. Calling it as, say, S. So what is cardinality of S? The approach is very similar to the last question. Like, you discuss, you tell me like your opinions. If we are in tandem, we'll just move on. So please. So we have S7. And how many elements of order 7, order 12 are there in S7? That is the question. See, there are the set of answers consist of even like, I don't know, I can't figure out, etc. also. Fine. So it's not an issue. So what are the possibilities that, this will be cycles for sure. Anyway, one single cycle cannot make 12 from S7. So the possibility of devices of 12 are 12 can be 6 times 2 or 3 times 4 or 1 times 12. These are the possibilities of like factoring 12. So this is of no use to us as well as this. So this is the only possibility which we can try. Okay, I'm receiving some answers, but frankly I haven't calculated. I just have the formula. So I'll just tell you the thing and you can calculate and just cross check. So this is the only thing, 3 times 4. So it can be a 3 cycle ABC and a 4 cycle DF. So this is the only possibility of an element having order 12. So how will you choose? How many are there? How many of this cycle representation are there? Or cycle composition are there? We have total 7 elements. So we can choose for this, we can choose 7C3 into 2 minus 1 factorial, sorry, 3 minus 1 factorial. Yes or no? That is a cycle, permutation of cycle. So there will be n minus 1 factorial permutations. And so we have taken 3 already. So we have left with 4 and we are supposed to take 4. So 4C4 into 4 minus 1 factorial. You can take the other way also. You can take this way also. 7C4 into 3 factorial and we are left with like 3C3 into 2 factorial. Whichever way you go, you are going with 7C3 into 3 factorial into 2 factorial. And this you can compute and tell me because I haven't calculated this yet. Is it 210 or like 420? The answer. Is that clear? The idea is clear or what? I want to know if the idea is clear.
Yes, sir.
So shall we move on? I think answer is 420. So if there is no difference in opinion, like, shall we? So this is how you do this. Okay. So another question, like, okay, we'll just do with one more type of cardinality because these questions are being, repeatedly asked in the examination. So we'll just go with one more cardinality question and we'll leave some result there. So what is the cardinality of SL2 of F2? Which I mean, before that, let me ask you, do you know what is SL2 of F2? This is also called SL2 of Z2. I mean, have you heard of something called SL2, special linear group of matrices
Special
of
linear.
order? Yeah, special linear group of matrices of order 2, taking elements from or entries from. We shall go for the general thing, FP. You can go for FP. Why should we confine ourselves to F2? So this will be SL2 of F2, sorry, FP. So what is it? What does this mean? What do we mean by SL2 of FP? I mean, don't tell me the special linear thing again. I mean, what does it mean?
Elements come from the set FP.
Yeah, it takes elements from FP and
And
any
determinant
properties.
should be equal to 1.
Determinant should be equal to 1. Exactly. So for this particular thing, do you know that this is a subgroup of GL2 of FP? So we'll start from here. How many elements are there in GL2 of FP, which is the general linear group of order 2 in under FP, which means that this consists of all invertible matrices taking entries from 2 by 2 invertible matrices taking entries from FP, and that also means GL2 of FP contains matrices which are having non-zero determinants. So if I define a map determinant from GL2 of FP to say FP star, can define a map determinant from GL2 of FP to FP star, because there is no element of determinant 0 in GL2 of FP. Will this be a surjective map? Will this be a surjective map?
Yes.
Yes. Somebody says yes. Anybody has a difference in opinion? So if there is no difference in opinion, we'll just go with the answer yes. So this is a surjective map. And will this be a homomorphism? I mean, before that, I'm assuming many things since your exam is next month. So I assume many things that you know. Like, do you know what is a homomorphism?
Yes, sir.
Okay, fine. So will determinant map be a homomorphism?
Yes, sir.
So what do you call a surjective homomorphism?
Yes, sir. It's homomorphism and one-to map.
Yeah, it's a homomorphism and onto map. So what do you call what do we call that?
Epimorphism.
Anyway, it's fine. So we're considering this particular map determinant from GL2 of FP to FP star, which is a homomorphism. And we have cardinality of FP star equal to P minus 1. Let it be there, we'll use it later. So now, what is the kernel of this homomorphism? Kernel of mapped it. What do you mean by kernel of a? Yeah, what do you mean by kernel of a homomorphism? Like all the elements in this group mapped to
Whose
the
determinant
identity.
equal to 1.
Yeah, I mean kernel means all the elements of this group mapped to the identity of this
Identity
particular group.
element of second.
Yeah, exactly. So I appreciate that. So kernel of determinant will be
One.
I mean
SL to FP.
see, a kernel is something which we, I appreciate that.
Yes.
Let me come back to you. So, kernel is, somebody said one. I just want to clarify for her. So, the thing is that, see, kernel should be something on the domain. Okay. So, we have on the left hand side, on the domain, we have a collection of
SL2
matrices. Yeah, we have a collection of all matrices on the left, and on the right we have numbers. So kernel should be something on the left, so it should be SL2FP. And on the right, as you said, like it's not the kernel, but the kernel elements will be mapped to 1. So we have the kernel of the will be SL2FP. So what does first isomorphism theorem say? First isomorphism theorem says
Order of GL2FP,
Yeah,
quotient
order of-
cardinal isomorphic equal to order of FP star.
that's it. Order of GL2FP divided by order of kernel equal to order of image of F. Image of it in our case, kernel of. So now we have now we have, we know that image of F contains p minus 1 elements, and our kernel is what we need to find. So we'll just interchange this. So we need to find this. How many elements are there in GL2FP? How many elements are there in GL2FP?
P square minus 1 and
P cube times P minus 1.
Excuse me, come again. Somebody was saying p square minus 1 into.
P square minus 3.
Okay, so this is the correct answer. And for all those people who don't understand, what happens is GL2FP is some matrix of the form like ABCD, where this is an invertible matrix. So invertible matrix also means that it's a full rank matrix. Full rank matrix means the columns or the rows should be linearly independent, and that means I can have this thing and this thing. I must have these two things should be linearly independent. Fine. So first I'm choosing this particular column. Let it be. So I have how many ways of choosing? So I have total p square ways of choosing this, but there is a possibility of 0, 0 coming. So I am removing one option from that. So I have p square minus 1 options in choosing this particular thing. After I made that choice, I have how many choices left for choosing this column? So there is a column here. Still, if I have p square minus, of course, we are removing that p square minus 1 choices are there, and we should also remove those p minus 1 multiples of the first column. Yes or no?
Yes.
So
Yes.
please repeat again.
So in the first column, we have total p square possibilities to see. How many choices are there for A? 3 choices are there. How many choices are there for C? We are working on a FP, right? We are working on FP. So we have P choices for A and P choices for C. Yes or no? Suppose you are working on Z3 or F3. So how many ways you can
Yes.
choose A? 0, 1 or 2. So you have 3 choices. Similarly, how many ways you can choose C? 0, 1 or 2 again. Yes or no?
Yes, sir.
So we have total how many possibilities choosing A comma C, the combination. So I have one, see, suppose I
Yes,
am
sir.
taking A equal to 0, then I have 3 choices for C. I have A equal to 1, there are 3 choices for C. I have A equal to 2, still there are 3 choices of C. So I have total 9 choices, that is 3 square choices for the vector, the column vector AC. Yes or no?
Yes, sir.
Yes. But among that, one is the vector 0, 0. Isn't it? So
Yes,
what
sir. It
happens if I
would be
take 0, 0, 0, 0, if I put 0, 0, that will make my matrix non-invertible. So I cannot choose 0, 0. So I am removing that option p square. So total p square options are there. I am removing that option of 0, 0. So I have p square minus 1 options. Yes or no?
yes, sir.
Yes. Now coming back to the second column. So there also we cannot say same choice is there. Similar to AC, I can choose BD also. There are p square minus 1 possibilities are there. Yes or no?
Yes, sir.
But the question is, I need linear independence. So there I cannot afford to admit any possible linear factors or linear multiples of or any scalar multiples of the vector a comma c. Yes or no?
Yes, sir.
Yes. So how many scalar multiples are there for a comma c? Sorry, the vector ac. Or else rephrasing the question,
P.
how p minus 1, like how many scalar exactly, okay, p, let it be p. See, we have accommodated 0 case already, otherwise total p square choices, of which we have total how many number of scalars are there in fp? P number of scalars. So total p square choices, so if we haven't included 0 in the case of bd here, so total p scalars are there, so p choices for scalar multiples of AC are there. So we have total p square minus p choices for BD. Yes or no?
Yes, sir.
We have 0 times AC, 1 times AC, 2 times AC. So that is, I mean, if we are working on the previous example, Z3, F3. So we have 3 square. The possibilities are total 3 square, of which we cannot take 0 times AC, 1 times AC, and 2 times AC. Yes or no?
Yes, sir.
So that is how you get to this formula. So that is number of elements in GL2 FP. Paka? All clear?
Yes, sir.
Okay, now back to the question. So now this thing is actually p square minus 1 into p square minus p divided by what is image of determinant? That will be p minus 1. This will be the cardinality of SL to FP. Okay, I mean, this is a general formula. The question might be coming like for some specific p. So this will be p plus 1 into p square minus p the whole divided by, there is nothing to divide. It's already cancelled. P square minus 1 and p minus 1 are already cancelled. So the cardinality of SL to FP will be p plus 1 into p square minus p. Fine.
Yes.
So now what is the cardinality of SL to F2?
Six.
6. Fine. That's it. So all good. Any questions?
No, sir.
Okay. So are we going like I mean going fast or like please mind to interrupt if you feel that I'm going fast. Okay. So now another question. My question, like say real numbers under addition and complex numbers under addition. I mean, do they form groups? Are they groups? Normal addition.
Yes.
Yes. So I have a doubt like whether they are isomorphic. Are they isomorphic?
Geometrically, yes, but algebraically not.
I mean, if they are isomorphic, they should be. He said something called geometric isomorphism and algebraic isomorphism. Like geometrically, we use more like isometry, not isomorphism.
Sorry, sir. Sorry, sir. Yes.
Okay. So in this case, are they isomorphic? But the catch of this question is, they are isomorphic, but the catch is that you won't be able to define a specific isomorphism unless you use something called axiom of choice. Have you heard of that? Anyway, I'm not overfeeding you with information, so leave it aside. So the idea is we'll take the quotient over Q, R over Q, and C over Q. This will be both these are vector spaces. Yes or no?
Yes.
Yes or no?
Yes,
R
sir.
over
This
Q,
form.
yes, they are vector spaces. Yeah. So if they are vector spaces, and are they isomorphic in the case? Either does there exist a vector space isomorphism between them? Because if there exists a vector space isomorphism, then the only thing is that the bases should have a Same cardinality. Should have the same cardinality. Yes or no?
Yes, sir.
So what is the cardinality of the basis for R over Q? That is the cardinality of irrationals. That will be the cardinality of real numbers as well. And that is the cardinality of complex numbers. Seen as R cross R as well again. So there exists a vector space isomorphism of which you can find, you can establish the existence of a Hamel basis, but you won't be able to explicitly define one. Anyway, if they are isomorphic as vector spaces, are they isomorphic as groups? That's a simple yes or no question. A vector space is a group of what?
Yes, sir.
Okay. And the rest is history, or you can just think about it. Now, one more important question. Like again, I'll share. Like last. This one. Yeah, this one. Can we do this now? So let G be a group of order. This is the maximum I can do. So let G be a group of order 2022. Let H and K be subgroups of G of order 337 and 674 respectively. If H union K is also a subgroup of G, then which one of the following is false? Do you understand the question? Before going to the options, let me ask you, do you understand the question? Can you
Yes,
read
sir.
the question? Can you read the question? Anybody who is not able to read the question?
Given the order of group is 2022 and H and K are subgroups with order 337 and 674 respectively, I'm assuming that H union K is a subgroup of G, then which are false?
Yeah. So now let me come to the question. Let me ask you some question out of this before going to the options. So what happens, when H union K is a subgroup of G?
One properly contained in another.
One should be properly contained in the other. Yes, fine, Pakka. Anybody having a doubt in that? Anybody who is not clear on the case where H union K is, anybody wants a clarification on that? Why H union K should be, H union K is a subgroup implies one should be contained in the other. Anybody having a trouble understanding that particular thing? Please respond. Okay, it's all clear. So I assume that. So now look at the numbers 674, 337, and 2022. So now you might have already identified 674 is 337 times 2, and 2022 is 674 times 3. You might have seen. So what is the bigger group is the bigger subgroup is K and the smaller subgroup is H. Clearly H is contained in K. So we'll go to option number 1. So H is a normal subgroup of H union K. So now by now you might have understood H union K will be, if H is properly contained in K, H union K will be
K.
K. So the question the option transforms to H is a normal subgroup of
K.
K. So how are you going to address this particular thing? I've given you order of H is 337 and order of K is 674. So
Index.
exactly, we'll go for the index. So what is the index of K or H? Index is 2, and that makes H. Shall I explain that again? This looks direct things, so I'm not explaining. So if index is 2, will that be a normal subgroup?
Yes, this is true.
Yeah, because there will be only 2 cosets, and one is a trivial coset, like the group itself, and the other should agree for sure. So when the index is 2, it will be a normal subgroup. And second option, the order of H union K is 1011, 1011. Is that so?
No, sir.
Why?
Because H union K is K, the order of K
And that
is
makes the option false. And inadvertently, the option C becomes true.
yes, sir.
And for the last option, K is a normal subgroup of H union K, which is K is a normal subgroup of K, which is in fact
True.
statement. I mean, see, do you see the catch? All the 4 options can be easily identified and all can be easily tackled only if you know, like, that can be identified on the go, at a stretch, only if you know H union K is K. Yes or no?
Yes, sir.
So the only thing you are supposed to know is that H union K is K. So that is a catch. Understood? Any props? Yeah. So shall I explain further on this, or like shall I move on?
Yes, sir. No problem.
Yeah, we'll do next question. Yeah, we'll do this. Consider the group rationals under addition and its subgroup integers under addition. Okay. For the quotient group Q over Z, which of the following is false? We'll go with option 1. Q over Z contains a subgroup isomorphic to Z plus. Q over Z contains a subgroup isomorphic to integers under addition. Opinions, please. Okay, I'll give you a hint if you have an issue to solve looking at it. So what do you mean by Q over Z? Set of all elements of the form A by B plus where A and B are this and A B equal to 1. B not equal to 0. This will do, but still. Yes or no?
Yes.
Yes, sir.
Yes. So that's it. So and integers under addition, of course, you know what it is. So now are they isomorphic? Isn't that? Yeah. It contains a subgroup isomorphic to Z plus. I mean, okay, fine. Which property or which idea are we going to use here?
Order of element.
Exactly. I appreciated that. I appreciate that. So we have all the elements in Z plus. What are the order of elements in Z plus? What are the order of elements in integers?
Infinity.
Infinite. Fine. And what are the order of elements in Q over Z? If you see, look at the expression.
Finite.
Finite. Any number you take, it will be of the form A by B plus Z, where if you multiply by B or add it B times, what are we getting? If we add
Z.
this element, we are getting the identity. Yes or no? So we have all the elements in this particular thing are finite as well as, whereas, I mean, this is a group in which all the elements are None of the elements have finite order. Any other property other than this? One more property we can use here. This is cyclic, no? Yes or no?
Yes, sir.
Yes.
And what about this?
But we just need subgroup, right? So we can't really use that.
Exactly. So we'll just go to the next option where we'll use that option. Anyway, we'll have to use it somewhere. So there is exactly one group homomorphism from, we'll come to the option B later. Okay, so for question, option C, for all n in n, there exists G in Q over Z such that the order of G is n. Is that true? For all n in n, there exists an element G in Q over Z such that the order of G is n.
True.
True. Why? Can you give me an example?
1 by n plus n.
Exactly. So we have 1 by n plus Z is contained in Q over, and this element will have order n. And that's as simple as that. And we have already seen like Q over Z is a cyclic group. Yeah, do we have a generator for Q over Z? What is the cardinality of Q over Z? Anybody please? What is the cardinality of Q over Z?
Infinite.
Infinite. And what are the order of elements in Q over Z?
Finite.
So that is the very explanation in daylight that Q over Z is not a cyclic group. Why? Because the group itself is infinite ordered and all the elements are having only finite order. Yeah. Now back to the option B. We have seen all A, C and D are true. Now there exists only one homomorphism from Q over Z to Q plus. Is it true? See, the option A is false. Sorry, mistake. So is option B true? Is option B? Any opinions on option B? There is exactly one group homomorphism from Q over Z. See, let me tell you something. Like, if you are in a learning phase, consider all the question as multiple select questions. That means you might have multiple correct answers. Okay, so that you explore all the options. Don't stop when you get a like which of the following is false. You get the first option false. So that doesn't mean that you don't have to explore the other options when you're learning. And of course, in an examination, if you're writing the examination, you're writing a multiple choice question, you know that only one choice is there, like you can move on. But when you're in the learning phase, consider all the questions as multiple select questions which might have multiple correct answers. Clear? Clear?
Yes, sir.
So what about the option B? There is exactly one group homomorphism from Q over Z to Q plus. Does there exist at least one?
Yes.
Which one is that?
Trivial homomorphism.
The trivial homo. Exactly. And why no other homomorphism?
Order of elements in Q of Z is finite.
Exactly. Order of elements on one side is finite and order of elements on the other side are not finite. That is all. That is what we were talking all the way. Yes or no?
Yes.
Yes, sir. Yes.
Yeah. So we'll do one similar type of question. Like, have done this now. Yeah. This one. Which of the following statements is true? I mean, this is very much similar to the previous one, so I just want opinions from your side. So, who is gonna tell me what is happening with option A?
False.
False. Why?
Z plus is cyclic.
Z plus is cyclic and R plus is non-cyclic, of course. Another option is you can have the cardinality check also. And second option.
Countable and uncountable.
Exactly, countable and uncountable. One is have a left node and the other is having infinite continuum. So, the second option, Z plus is isomorphic to Q plus.
True.
I mean, that doesn't make any difference. The same ideas. No. Wait, what is the difference between option A and option B? There is one difference, that is you cannot use the cardinality property, but you can still, the cyclic thing is applicable in option B also, because Z plus is cyclic, whereas Q plus is
Non-cyclic.
non-cyclic. Similarly, I mean, we'll come back to C, but option D, which we have already discussed. I mean, do you have any doubt on option D? We just discussed it immediately before this one. Isn't it? I mean, Q over Z under addition is isomorphic to Q plus O what? One is having finite order, the other one is having, I mean, all elements are of finite order. The other one is having all elements of infinite order. So they are also not isomorphic. Now back to option C. So Q over Z plus is isomorphic to Q over 2Z plus. This is rather interesting, like proof. Like, let me tell me, is it true or false? Q over Z plus is isomorphic to Q over 2Z plus.
True.
It's true. So, shall we go check why? So, we'll do one thing. We'll just define a homomorphism from Q. Let me define a homomorphism from Q to Q over Z. Okay, can I? I'm defining phi of x equal to x by 2 plus z. Can I?
Yes, sir.
Will this be a homo? Will this be a homo?
Yes, sir.
Okay. So now what is the kernel of? I mean, this is bijective also, you can check. Isomorphism.
2Z.
Exactly, 2z. And what does first isomorphism say? Q, which is this Q, over the kernel 2z is isomorphic to the image Q over. Right. Doesn't that look good? Like,
Yes, sir. Very interesting.
yeah, I mean, so the option C, which is q over z plus is isomorphic to q over 2z plus. But we haven't used directly any isomorphism between q over z and q over 2z. But we have deduced it from a map from q to q over z, and we have used this property of first isomorphism theorem. Any question on that?
Sir, can we replace 2z by any nz where n is natural number?
This function plays the role. I mean, you might have identified by now. So, if we take x by 3, what happens? What is the kernel of
3z.
So that's it. So, does that make it clear to you?
Yes, sir.
Yeah, all good. Now, let me see one important problem which I've seen this question in two of the question papers, but it needs a kind of little explanation. Just see this. So, can you see? Let sigma be a permutation in S5 given by sigma is equal to 1, 2, 3, cycle 1, 2, 3 times the composition cycle 4, 5. Just check, please. Yes or no? It's sigma be permutation in symmetric group S5 given by sigma of 1 is equal to 2, sigma of 2 is equal to 3, sigma of 3 is equal to 1, 4 equal to 5, and sigma of 5 equal to 4. What does that mean? 1 goes to 2, and 2 goes to 3, and 3 goes to 1. That is cycle 1, 2, 3. I mean, I hope you know how to write cyclic representation from this. Yes or no?
Yes, sir.
Yeah, all good. So we are defining n sigma, which is a normalizer we call. Before that, have you learned group action or something like that? So I should know which perspective should I go for. Have you learned something called group action in your syllabus? Centralizer, class equations. Okay, so I mean, if you haven't learned this, we won't be stressing on. There is something called. I mean, I'll just tell you the approaches which I plan to. I mean, I'll explain the question, then I'll tell you my approach. So we are defining n sigma to be all those tau in S5, all those permutations in S5 which commutes with sigma. Okay. So the question is actually how many number of elements commutes with sigma in S5. That is the question if you rephrase that. So that can be approached by something called an orbit stabilizer theorem, which says stabilizer of cardinality of group is equal to cardinality of centralizer into cardinality of stabilizer. So, but we don't go for that since you haven't learned orbit, class equations, centralizer and all. But you have to know centralizer. I mean, that is same as normalizer here, n sigma. So that is one approach which I plan to go. But then I thought about, have you not, I mean, had you not studied these things, that should not restrict you from answering these type of questions. So I have, I mean, I'll just give you the formula for the centralizer. So you can use that formula for centralizer, and you can use the another formula which I'll tell you. Sure. So if you have the value sigma, which is a 3 cycle, if you have like say sigma is equal to say rho 1 raised say if we have a permutation of say permutation having n I cycles, ni number of cycles of length ri. Okay, suppose sigma is a permutation in which all the cycles of a particular length ri are repeated ni times. Okay, Then we have a formula for C of x. As of now, don't confuse about C of x. Let it be C of x, and let x be unknown. Whatever it is, will be product over I is equal to 1 2. Number of cycles, however it may be. Ni into Ri power Ni. So Ni factorial into Ri power Ni. Clear? This is the formula which, I don't know, if you don't know class equation, you are supposed to by heart this, but too many questions have been asked from this, so can't refrain from seeing this. So if sigma is a permutation, which, like, say, I'll give you an example. So suppose sigma is equal to 1 2 3 4 5. In S7, if we have 1 2 3 4 5, we have only 1 3 cycle and 1 2 cycle. So N1, if we take R1 is equal to 3 and N1 is equal to 1, R2 is equal to 2 and N2 is equal to 1. There are 1 3 cycle and 1 2 cycle. So, but if you have something like this, then if you take similarly R1 is equal to 3, there is only 1 3 cycle, so N1 is equal to 1, and R2 is equal to 2, we have N2 is equal to 2. Why? Because we have 2 cycles. That is how you substitute for the values. Clear?
Yes, sir.
Clear? Yeah. So we'll use this formula, and we have another formula saying cardinality of G is equal to cardinality of C of x to cardinality of S. Okay, and this is how we need to find. This is order stabilizer theorem, but we don't go for this thing. We'll just refrain from this thing for the time being. But this formula will give you the number of points which we compute. Shall we compute that? Can you help me with that? So this is the question. So our permutation is sigma. In S5, we have sigma is equal to 1 2 3 4 5. So can you use that formula for C of x and tell me what is the value we are getting? Have 1 3 cycle and 1 2 cycle. Exactly. So we have the formula to be 1 into 3 power 1. 6. So there are 6 elements which commutes with 1 2 3, 1 2 3 4 5. Shall we do one more example? Maybe. Say in S9, say sigma is equal to 1 2 3 4 5 6 7.
Twelve.
Yeah, we have that to be 12. Similarly, if I go for like 1 2 3 4 5 7, this is the case. How many elements commute with 1 2 3, 1 2 3 4 5 6 7? Anyway, that's a simple computation. Fine. So that is how we do this thing, and we'll do one more if we have time.
Sir, in S9, 1, 2, 3, 4, 5, 6, 7.
Excuse me.
In S9,
Yeah, we have 1 3 cycle and 2 2 cycles.
in
So the
sigma,
formula,
1, 2, 3.
yeah, 1 2 3 4 5 6 7. That will be 3 times 4. So this will be 3. So 1 times 3 power 1 into 1 times 4 power 1. So that will be 12. And here it will be
2,
1 times
2,
3.
1, 6,
Yeah. Come again, please.
8.
You're not clear to me. Please come again.
2 uncycles are there. No? 2
I mean,
uncycles are there.
of course, you can compute that if you want. 1 into 1 power 1 and 1 into 1 power 1.
Sigma is a 3 cycle and a 4 cycle.
Yeah, I mean, if you want, you can use 8, 9. It's fine.
Sir,
It's fine.
and tau also the same cycle type it must be. Then only it will permute. Is it correct, sir?
No. It will commute only when you are correct. There should be of same cycle type. That is what we are finding.
Yes, sir.
The centralizer will be of the same cycle type. Of course, you can use that formula also. If you, I mean, you can just go for the formula which we in the starting we have discussed some number of elements of a particular cycle type, like somewhere 3 times 4, like some element of order 12 in sets S7. Similar thing you can apply here also.
Yes.
That will work. That also can work. Fine.
Oh, yes. Okay.
But I mean, this is, I mean, you're preparing for an examination, so that I thought of giving you the formula. But the other one, that is the concept actually. I mean, centralizer means actually the elements of the same cycle type. Same, exactly. So somebody was asking me, we have 2 1 cycles. I mean, that's fine. If you substitute that, still you are getting times 1 times 1. There'll be 1 into 1 square. Yeah, 2 1 cycles. 1 into 1 square. Sorry. Okay. Sorry, 2 into 1 square. Sorry, excuse me. My bad. 2 into 1 square. So that is the formula. Any questions, anybody? I appreciate that. I mean, I made a mistake there. So I restrain with 1 into 3 power 1 and 1 into 4 power 1. But you have to do that 1 cycles also. You have to include that 1 cycles also. Similarly here also. You can go for 1 into 3 power 1 and 2 into 2 power 2 and again 2 into 1 power 2. That will be your number of elements that commutes with tau or n tau in the, like, as in the formula, like that is the value of n tau. We'll do one similar problem again. Yeah, the same question. Question number 27, but it is written wrong. Let G be an element of S7 such that G commutes with 2643. Please ignore the comma. There is no comma there. The number of such G is. Anyway, that's again computation. Just please feel free to use that formula and compute that. So we'll just finish with the last, second question, which is beneath that. So let G be an abelian group of odd order. Consider the following 2 statements. Statement 1 says the map f from G to G defined by f of G is equal to G square is a group isomorphism. And second thing, the product taken over all G in G, G will be identity. So if I keep a poll, I need some answers here because it's the last question. So how many of you say this is the first one is true, and how many of you say the second one is true, or how many of you say both are true, and how many of you say the both are false? Anybody there? Anyway, the issue with the second thing is, the peculiarity of the second thing is, if you take the product of all G in G, you are actually multiplying elements as well as their inverses. So that is directly, that is a direct inference that the second thing is, option 2 is
2 is true.
okay, fine. And the first one,
True.
So G is a finite abelian group of odd order. So G square is G going to G square is a homomorphism. Why? Because the group is abelian, because xy the whole square will be xy into xy, and you can swap the middle one. So you'll get it. Let's write that. So xy the whole square will be xy xy. This is xx yy. This is x square y square. So you'll get a homomorphism, and you can prove that the kernel of this homomorphism is identity. Why? Because this is a odd order abelian group. So the only element in such a way that f of g equal to g square is, or f of g equal identity. So hence it is an isomorphism. And with that, I plan to wind up the session. Hope you people got something from it. Thank you.
Dear participants, now it is a time for interaction. Okay, you can share your comments about the lecture, and you can ask any doubts if you have.
Sir, I have a question.
Please.
Sir, why is the determinant map from GL to FP to FP star is subjective? Which why?
The map should be subjective. Why? Because think of a matrix C. Say A001. Think of a map. Can you see my screen now?
Yes, sir.
Yeah. Think of a matrix like A001. What is the determinant of this?
A.
Okay, fine. Determinant of this thing is A. And how
Okay,
many ways
okay,
I can
got
fill
it.
in A? Fine. Any more questions? Anybody?
Okay, yeah, Aravind, you may please switch on your video if possible.
I'm having a 4% charge on my phone, sir. So I am afraid I can.
Yeah, participants, if you have any doubts, you can ask now itself. Otherwise, we can move on to, you can share your comments about the lecture. Sayanta, could you introduce yourself?
Sir, I qualified master degree from Presidency University, Kolkata.
Presidency,
West Bengal.
okay, Calcutta, okay, thank you, Sayanta. Yes, others?
Hello, sir.
Yeah.
I'm Gayatri. I have done my graduation from Miranda House College, Delhi. The class was really nice, sir. It was really interactive and which helped us to understand more. And you have discussed some of the questions and the explanations were very clear. Thank you, sir. Thank you so much.
Thank you.
Okay, thank you, Murthy.
Hello, sir.
Others? Yeah.
Kundo, West Bengal. Question is interesting. Question selection is very nice. Yes.
To be precise, let me say something. Group theory is also a very tough topic for me also. But see, we should address our fears. So I'm theoretical cryptographer. I'm not doing any group theory stuff for past 5 years, but still, I took this opportunity. So address your fears, please.
Okay, thank you, Harita. Others? Yeah.
Good evening, sir. I am Dharmendra UP, and now from Visakhapatnam. I am doing library job and I am preparing for IIT JAM also. Session was very nice and program also very nice from IIT JAM and other how should we do multi-selective question? That are very tough type question. For that,
I
what
see.
type of practice we should do?
See, multiple select questions are like it is all. I mean, there is no speciality between multiple select and multiple choice questions unless there can be more than one options correct. So that is why I insisted that when you are learning, address every options. Like look at every options, and by fault sometimes some two options, even in a multiple choice questions, by mistake it can happen that some two options are can be correct. So address every option
Yeah,
and
yeah.
see why some options are right and why the others are not correct. I mean, why others are not matching. So when you are writing the examination, we make it clear in your mind. We are writing a multiple choice or multiple select. But when you are learning, all the options should be addressed, and you should be direct. You should be very clear why you are avoiding an option and why you are choosing one. Both you should mean. Not, mostly people choose. People are sure why they are choosing an option, but you should be all as equally. I mean, usually you are responsible for equally avoiding an option also. So you should be responsible for choice as well as discarding.
Yeah, sometimes it create very confusion. So I asked it. What
Very good
type?
question. That's a very
Which
relevant
books?
question.
Which books you can suggest?
I mean, which subject are you
Other
asking? For
than
group theory, I mean, for any kind of algebra, I'll suggest as a beginner. I suggest Joseph Gallian as a beginner. And if you have learned something and if you want to, like, say, a refreshment or, like, say, kind of uh, something like that, then I'll suggest Frale.
Frele is advanced, then Galen.
It's advanced than Gallian because Gallian you have plenty of examples. More, you have more number of examples in Gallian than in Frale. And they have
Uh,
written in such a way that in a simple language also. So for a beginner level, very beginner level, I'll suggest Gallian. And if you know something or like if you have a capacity to catch up fast, I'll suggest Frale.
yeah. Okay. Thank
I
you.
mean, and I also recommend don't start with Artin and all from the very beginning.
Yeah.
Okay, thank you, Dharmendra.
Sir.
See, that point mentioned by Aravind is very important. While answering a question, you should be very careful about the options also. So there will be many things can be learned from why we are discarding such some options. That should be analyzed. Then only you can understand more ideas related with that problem. Okay, thank you. Others?
Excuse me, sir. One query also.
Yeah,
From where we can get Galen solution? Sometime many problem very typical.
I mean, I don't know if you have a PDF or some solution manual for Galen. I don't know if it exists. Sorry to disappoint, but better you can have a session with somebody or like you can have so you can solve by yourself, and if you don't have confidence in, you can ask your friends or some teachers or somebody else to correct yourself, so that maybe if you do 2-3 sessions like that, then you'll get confidence in your solutions and you can check for yourself. You don't have to use a solution manual or something like that.
Yeah. Thank you, sir.
Okay, thank you, Dharmendra. Others? Yes.
Hello, sir. My name is Aparna. I'm a graduate from Kerala. Actually, sir, today's session was very wonderful and thank you so much for your tip. Even I have some difficulty in grasping all these concepts of group theory. So, today, the way you taught us and the tip on MSQ, because I have very difficulty in solving those. Because while doing, Vinod sir always conducts its test series, and in that, the majority of questions which I am getting wrong is on MSQ. So thank you so much, sir, for giving us that tip on MSQ. And sir, thank you so much for spending your valuable time with us. Thank you, sir.
Yeah, I recommend that you practice MSQ because for net and all, you can score more on MSQs than MCQs. So if you're aiming for a long run, not just jam or gate or something like that, if you're aiming for a net or some NBHM or something like that, so I mean, better prepare from MSQ from right now onwards. So you won't have a like discretion between MCQ and MSQ. Anyway, you have to choose options. You have to choose between options is also an option.
Yes. Okay, thank you, Aparna. Others?
Good evening, sir.
Yeah.
I'm Nishita Pendharkar from Maharashtra. I'm TYBSc Mathematics student. Sir, today's session was very interesting, and I'm very thankful for sparing such time for us. And I'm very thankful to Vinod Kumar sir also for making you available for us. And thank you so much.
Thank you, Nishita. Yes, Sahra, you can speak now.
Sir, myself Zahra Rumesa. I'm from TMG College. And first of all, thank you so much, sir, for your valuable time spending with us. And nice explanation. And thank you, Vinod sir, for conducting this section. And thank you so much.
Thank you, Sahra.
Hi, sir.
Yes.
Sir, my name is I'm 30 from Kerala. And sir, and your explanation is very clear. Thanks, sir.
Okay, thank you, Arya. Any others?
Hello, sir. Hello, sir.
Yes.
Amrita, third year BSc Math student from ᴍᴜᴜ College, Kerala. And thank you, sir, for this wonderful session. The class was really nice. We clearly understood the questions you were discussed today. Thank you so much, sir, for sharing your valuable time with us. And also, I would like to thank Vinod, sir, for conducting such a wonderful session for us. Thank you, sir.
Thank you, Malavika.
Hi, sir. I am Amal. I am from Iritty Mahatma Gandhi College. Sir, the questions was very helpful and the explanations on every questions and with every options was so helpful and in our studies. Thank you, sir, for the informative session.
Thank you, Amal. Any others?
Hello, sir.
Yes.
I'm Andrea Sebastian from Assumption College, Energy. The class was really nice. You discussed the topics of previous year JAM. It's very clearly. Thank you, sir. Thank you, Vinod, sir, for conducting this session.
Yeah. Thank you, Andrea. Yes.
Sir.
Yeah.
So I'm Anamika E. I'm from Kerala. So the session was very nice and well clear. Thank you, sir, for this class, and thank you, Vinod, sir, for this session.
Thank you, Anamika. Any others?
Good evening, sir. Myself Shilpa. Thank you, sir, for conducting such a wonderful session. The group theory topic is one of the most difficult topic for me, and by attending this class, I have cleared many of my doubts regarding this topic. And thank you, Vinod, sir, for organizing such a wonderful session.
Okay, thank you, Shilpa.
Excuse me, sir, and sorry to interrupt.
Yeah.
Somebody has asked in a
Yeah.
chat, sir, can you suggest some good topics, good textbook to learn the theory behind elliptic curves? So it is from Abia Joy. So I need to learn why you want to learn elliptic curves. Like the question is, do you want to learn elliptic curves as such, or the cryptographic applications on elliptic curves? Like because the elliptic curves are mostly used in the cryptography applications. So
I want to learn the theory behind it.
Okay, you want to know, I mean, if you want to start with the theory, I suggest any good number theory book. I'm not into it, but if you want to let's know the application of elliptic curves or like how elliptic curves are used, I mean, basic theory will be there. So I recommend Mathematics of Applied Cryptography by Pfeiffer, Silverman, and Hofstein, Pfeiffer, Silverman, Mathematics of Applied Cryptography. So that contains basic elliptic curves, the theory behind it, and the application of that.
Okay, sir. Thank you.
Okay, thank you, Abhiya. Yes. Yeah, Lakshmi, you can speak now.
Hello, sir. I am Lakshmi. I am from TMG College, Tirur, Kerala. Today's class was really nice, interesting, and very informative. You explained each and every question very clearly, and your explanation was very easy to understand. Thank you, sir, for spending your valuable time with us, and thank you, Vinod, sir, for conducting this class. Thank you.
Thank you, Lakshmi. Any others? Yeah. Okay. Thank you, Aravind, for spending your time with us. I hope
Pleasure is
that
mine, sir, always.
yeah, I'm sure that today's session really interesting for the students because they have actively involved in the discussions. Okay, thank you once again.
One more thing, sir. Like one question has also come. Please tell how we can be ready for number 3 and cryptography also. So I mean, cryptography. I mean, if you are a UG student, I don't recommend that you directly go into number theory based cryptography as such. But if you're too much interested, I recommend that you read the same book, like the suggested one, Mathematics of Public Key Cryptography by Hofstein, Pfeiffer, and Silverman. That contains the basics of, public key cryptography is the mathematics of cryptography, but the other one, the symmetric cryptography, mostly considers the architecture-based things. So if you want to do mathematically, so I suggest you read this. And beyond number theory now, actually, currently what is happening in cryptography is like it's going past number theory, and we are switching to something called lattice theory and coding theory. So if you want to learn cryptography for real, you don't like limit yourself to number theory. You have to see lattice theory as well.
Okay. Okay, thank you, Aravind, for being with us, and wish you all the success in your research career. Once again, thank you, everyone. Let us wind up here.
Thank you, sir.
Yeah.